Hello viewers, this lecture is based on the pH and pOH. Plus, we're going to discuss about the Kw, that is called the water constant. So let's first look at this Kw. As you know, the water that we usually drink, we all know that it is neutral. As I told you in my previous lectures about the Arrhenius theory, in Arrhenius theory, this aqueous solution plays the vital role in both the classification of the base as well as the classification of the acid. In the base, the water produces the OH ions, and in the acid, it produces the H ions. In both of the condition, the one contaminant, that is water, it works as both acidic and basic. Now, according to the concept of the water ionization or Kw constant, we know about that the Kw constant, that is an equilibrium constant of the water, and in equilibrium constant the product is written upwards and the reactants are written downwards. Now here the product is this and the reactant would be H2O. So we're going to simply write the classification according to this. So let's write it. It would be OH, then H divided by H2O, and that is equal to, let me remove this one, and that would be equal to Kc, equilibrium constant. Now here this H2O is multiplying, after going there it will here it is dividing, after going there it will multiply. Let me write this here. So it will be something like Kc, concentration of H2O, and that would be equal to this content. Now we know that this content combinedly is known as Kw. As I told you here, it is the equilibrium constant. So we're going to simply write that. Now after that, we know that the equilibrium constant that I just given here, Kw, that is of water. Now Kw is an ionic product constant of water and its value is approximately 110 raised to power minus 14 dm³. That's in constant. Mole per that would be mole per dm³ whole square, because there isn't any single concentration, there are two concentrations, so we're going to square that, and this is the proper value of the constant. This is simply what the Kw constant is. After that, we're going to study the pH. Now there is a derivation of the pH. So let's have a look at how the pH plus pOH is equal to 14. Now for that, we're going to simply write the equation that we have just have a look on that, on the Kw constant. So we're gonna write that equation, and we're gonna write the concentration and log of the both. Here you can see it's not here, it's here actually. After that, we know that this will remain constant Kw. That would be equal to, now we know that the basic, the acidic and the basic, these both are equal to 7 when talking about the water. So it will be equal to 7 plus 7, and that is equal to 14. Simple, isn't it? Now, here the thing that we noted is that the base are always greater than 7. And the acids are always less than 7. Let's have a look on that. Now here in this chart you can see that 7 here, the 7, this is neutral. Now in the neutral part there is only one thing, and that is water that reacts with both acids and the base. When it reacts with acid it becomes acidic, and when it reacts with base it becomes basic. After that you can see here the blood comes at the second, at the side of the bases. This is base and this is acid. So here you can see the 7 at the H, the basic, it is blood, then baking soda, then milk, then magnesia or ammonia, then soap, then bleach, then drain cleaner. At the acidic side you can see here the milk. Now here this is the milk of magnesia, and this is normal milk that we drink. Magnesia, then after milk is coffee, wine, vinegar, lemon, stomach, acetic acid. Now here one thing to be noted is that when you see here at this side the soap, ammonia, baking soda, blood, these all are slippery. Drain cleaner also, these all are slippery. If you talk about this one, these all are of sorties. That's why they are called the acids. I hope that the pH scale, pOH, and the concept of the 14 is now clear to you all. Thank you for watching.